So again, this is exercise number 6. You have a thermos. There's a cylinder surmounted by a hemisphere. So let's take a look at how this looks like. Maybe we can just skip the 3D look of this one. You know how it looks like. A thermos it is. Yes, this is a cylinder and surmounted by a hemisphere. So definitely, you know that this one is going to be your H. Now we don't have to write our cylinder or our sphere because the R of them is practically the same thing. And then this is just to scare you. A cylinder is surmounted by a hemisphere like object. Okay, so the first question the first part of the question requires us to actually rewrite the S formula into given, and if you take a look at the S of the container given in that particular question, it consists of only R's. Definitely pi is actually a value. Maybe it has infinite or just a specific symbol for it, but don't treat it like a variable. Okay, it's just another value. Now that you know about that one, definitely the S of hemisphere is just a half of the sphere. It consists of R only. Okay, that's okay. But for the cylinder itself, definitely you will have a combination of H and R. There are two variables over there. That is why you need to first rewrite this H in terms of R only using the constraint 45 pi is the given volume. Okay, so this one should be easier as compared to previously because we have touched the very first part, which is the basic example. If you have a V and then you're just going to rewrite the H using that V value. The only thing that we have to consider over here is the object is a combination of two 3D objects. So your V is actually equal to a V of the cylinder, which is a pi r square H, plus with the volume of the hemisphere. I'm going to write the volume of the hemisphere first. Since the sphere is pi r cube, so divide by 2, you will have a 2 over 3 pi r cube, plus with a pi r square H. So this whole thing is equal to 45 pi. Okay, so this is pretty much self-explanatory, where you have to actually firstly this one minus with 2 over 3 pi r cube on the both hand side, and then you're going to divide both sides with pi r square. Then this 45 pi divided by 5 divided by pi r square, you will get 45. The pi will be gone. Okay, you have just 45 over r square, and then this one, since on the other side it will become a negative 2 over 3 pi r cube divided by pi r square, you will have 2 r over 3 with the pi gone. Okay, so this is your H. Now that we are happy with our H, let's plug it into our S. So S is this one you have to be really careful because the hemisphere is actually blocking this top circular part of this cylinder. So instead of using 2 pi r square for the cylinder, it will only be 1 pi r square for the cylinder. And then for the hemisphere itself, since the sphere is 4 pi r square, then this one will become half of it, which is only 2 pi r square. Okay, so this is for the hemisphere, and for the cylinder it will be pi r square plus 2 pi r h, no change in the circular wall of this cylinder. Okay. Okay, so this part will become 3 pi r square. That is nice. Alright, then we need to change our h into the given part in the up here. Okay, so this one will be a 3 pi r square plus with a 2 pi r and a very long term for your h. So remember to treat your algebra carefully, and then you should be able to get 5 over 3 pi r square plus 90 pi over r as given in the first part of the question. Okay, so that is one down. One more to go, which is what is the value of the radius r if the total surface area is it maximized or minimized? But basically it's optimized in this case. So just use your ds dr, find it. It should be 10 over 3 pi r, and then this one will be minus 90 pi over r square. Let it equal to 0. You already know how to calculate this stuff. Okay, again, just simply pull the r to one side, and then this one is going to be 3 multiplied with 90, 270 divided by 10, it becomes 27. So r is a cubic root of 27, which is a 3. So since we only have one value and that value is positive, definitely this is already the final answer of this particular question. So, and that easy enough.